Okay, so how you make the pins that are used to stabilize the fish, basically the tiny pins that go through the notochord of the zebrafish. So you'd use these thinner tungsten wires, and this is the 0.005 inch tungsten wires. And you basically want to make just a whole bunch of them because they're small and they're easy to lose. So what I like to do is I like to take one of these tungsten wires. Right? They're tiny. They're tiny. So I just take one of these and then I pre-cut them and then I etch them so that I have just a whole bunch just lying there, and then I can etch them all at the same time. Or else you'll be going back, cutting and then etching and cutting and etching. So I have this again prepared, the power supply, right? And then the positive again goes to your forceps, which you will hold the pins with, the positive, and then the negative goes just to a silver wire and into the KOH, right? So again, you need to be able to look at what you're doing. So I like to do this underneath the dissection microscope, and then the length of the pin is really something that you want to compare to the larval zebrafish, so that you're not going too short or too long, right? Because if it's too short, then you won't be able to pierce the entire fish. But if it's too long, then it's too flexible, and then it'll bend really easily. Also, you don't want it too thick because you just want to penetrate the notochord, and then you don't want to damage any of the tissue, right? Because the spinal cord is right above the notochord, so you don't want to damage that, and you don't want to damage a lot of the blood vessels just ventral to the notochord. So you just want it just the right thickness. But if it's too thin, then it's not going to give you a good grip on the fish. So basically, again, you'll have to compare it to the fish, and then compare it to your own preferences regarding the thickness and then the length of the pins. So, just go ahead and just cut a whole bunch of pins underneath the. Well, here, this is underneath the microscope, right? So, just. They're going to be really tiny, so I like to just cut a whole bunch of them. And it'll be hard to see this, but you can just, I'm just cutting very small pieces of the wire, right? And then it's falling onto my plate. And after I cut a couple, I will just etch all of them together. Yeah, and you really want to just, if you're gonna do this, you might as well just make a whole bunch, so that you have a bunch of pins to work with. And then maybe have like a zebrafish ready so that you can compare the size of your pins to the fish to see if they're suitable. Right, so I think I have a whole bunch of pins ready to go. Now some of these might be too long, but that's not, it's not really a problem because you can just etch them. You really don't want them to be super long because there's the danger of them scratching your objective once you put them underneath the microscope, right? Because the clearance for the objective is only, what, like 2-3 millimeters. Yeah, and you definitely don't want to go above that, right? Because a part of it is going to go into the sill guard, but you don't want the part sticking out to be too long. Right, so you can see that there's just like these pieces of the tungsten rod on the sill guard dish, and then we just put this ground wire in, and then again the positive attaches to my forceps, and then I'm gonna power on again, and at the end, you can use whatever. I usually like to use between 5 to 10 volts. Usually 5 volts probably, and then it's pretty easy. You just pick up these pieces, these tungsten rods. Just dip them into the solution to get that sharp point. So I'm gonna use this one as an example. Maybe this one. Here we go. Okay, so I want to just manipulate it so that it's upright. This is there we go. And then, yep, you can see, you know when you've contacted it, right? Because the bubbles start forming. So again, it's that simple motion, just up and down until you have the thickness and the sharpness and the length that you want. Yeah, it's pretty obvious underneath the microscope how thick these or like what how far along you've etched it. And again, it's just, just play around with it until you get the shape and the sharpness that you like. All right. So so there's the one. And then there's a whole bunch of them and you just keep going until you have, I would at least make 10 to 20 pins. Yeah, if you're already going through the effort of making them, you might as well make a whole bunch. And I'll just show you what we use. So this is our plate. So these are the two stimulating electrodes. And then these 1, 2, 3, 4, 5 are the different pins that we use to pin the fish down, right? And then so I'll just take one out so that you can see about the size, the length, and the width of these pins. So I'm just going to lay this down like that, right? So like that. Now this one's slightly longer than I like. This one's about right. So it's like, I'm just gonna put this one back. This one's just slightly longer, and I mean, there's nothing wrong with this particular one. It's just slightly longer than I like, and there's definitely no danger of this scraping your objective, but it's just harder to keep it keep it straight because it's easier to bend. Now this one I like a lot. This is about the right length and then the right sharpness. It'll work well. All right, so and then you have you see this one here. This one's really thin and really short, and this one we use to go through the brain of the fish. So you don't want like a huge honking piece going through the brain, right? I want to damage as little as possible. So this one's shorter and smaller and thinner, just for the brain. And this one's funny. Weijun likes to use this one to clean her dissecting tool. So you get a bunch of skin and stuff stuck on your dissecting tool, and you just like rub it on this really thick pin over here just to get rid of all the debris. So you can make a wide range of pins for different functions.